Welcome to Civil Way YouTube channel, and today's topic is water budget equation. So before starting water budget equation, we have to understand first something about catchment area, what is ridge or watershed, etc. As you can see from this picture, the arrows coming from a at a height coming from at a height its contribute as it contributes this water body like river. So this whole that means the portion of starting the runoff from both the side, which ultimately contribute to this water body, and the enclosed area is called now catchment area. And the and the ultimate top where the contributing runoff started, these two this these two uh, this two hill type of structure is called ridge. So what is catchment area? The area enclosed through which runoff contributes to this river body. And what is ridge? The ridge where the runoff started and of contributing to this river. So this is ridge and this is catchment area. In USA, ridge is called as divide, and catchment area is called as watershed. Okay. So what is residence time? Residence time is the ratio of volume of water in a particular phase upon average flow rate in that phase, and the unit of residence time is unitless. Why? Because of volume of water particular phase, that is represented by m cube, and average flow rate is also represented by m cube. So same unit ratio, result is unitless. Now let us understand water balance. What is that water balance? Water balance is nothing but the total amount of water throughout our earth. And in this water balance chapter, we will understand the total amount of water which is usable and which is non usable. So worldwide water storage is 1386 m kilometer cube. In that storage, ocean percentage, as you can see, is 96.5%, and land and the rest water are present on land, that is 1%, usable but not drinkable. So total non-drinkable water non-drinkable water is 96.5 plus 1 is equal to 97.5. So here drinkable water, if we consider the whole amount of the water, approximately 100%, so the total drinkable water is 2.5%. So 1386 mk meter cube of 25.5% is result as 35 m meter cube. Sorry. So in this value, the glacier contribution in this value represent the drinkable water, in which 24.4 m kilometer cube contributes as ice cap as a glacier form, and only 10.6 m kilometer cube is usable and drinkable. So about 1386 m kilometer cube water, 10.6 m kilometer cube is only usable and drinkable as well. Now come to the water budget equation. We can understand this equation by simple income, expenditure and saving methodology. So how we can have the saving amount, like if one person income suppose x and his expense is y, then the saving should be income minus expense is equal to saving. So in relation with this, uh, in this equation we can have our water budget equation. That is, here as you can see from this diagram, there is a outflow, there is a inflow, there is a seepage, that is lost. So mass inflow minus mass outflow is equal to change in water storage. So here we can have, if density is equal to 0, volume of inflow minus volume of outflow is equal to change in volume of storage. Now if we denoted inflow as I, outflow as 4 and change in storage as S, so the water budget equation would be inflow minus outflow is equal to change in water storage. That's we all discussed earlier. Now we will see the parameters contributes inflow, contributes to outflow and type of water storage, which are varying time to time, which are varying by influence of this inflow and outflow parameters. So comes to the first point, inflow included following parameters, that is precipitation, which is represented as R or P. Outflow concludes following parameters, that is E, that is evaporation, groundwater infiltration, that is denoted by Z, and T is equal to transpiration. Now storage is of three type, that is S suffix X, that is surface water storage, S suffix S that is soil moisture storage, Sg is equal to groundwater storage. Now delta H, that is denoted change in storage, is equal to P minus R minus G minus T minus E. The annotation have their usual meaning. This is the equation of water budget equation. Now we can understand better if we take an example of on that. Like here you can see one numerical problem, that is like as a lake has a surface elevation of 103.2 meter above datum. In a month, the lake receives an average inflow of 6 cubic. In the same period, the outflow take place was 6.5 cubic. In that month, the lake receives a rainfall of 145 mm, and the evaporation from the lake surface was estimated as 6.3 centimeter. Using the water budget equation, find the water surface evaporation of lake at the end of this month. Surface area of the lake is 5 hectares. So here you can see all the units of inflow outflow are mostly different. Like this is cubic outflow, the precipitation is in mm, and evaporation rate is in centimeter, and surface area is in hectare. So if I using SI unit, we have to convert in same unit. So if we want to understand this problem by pictorial representation, here it is this is a water body, inflow rate is 6 cubic and 145 precipitation received, 6.1 6.1 centimeter evaporation occurs and 6.5 cubic outflow. And from the datum level, that is a arbitrary location, S1 is equal to 103.2 meter, which is given. After 1 month, this S1 would be decreases or would be increases. As precipitation and evaporation occurs, it may increase or decrease. So we have to find it. Let's write down some of the given point, like given data. That is, given data, inflow is equal to 6 cubic and 145. If we convert it in centimeter, we have 0.145 centimeter. Outflow 6.5 cubic and 6.1 centimeter. Now surface area is given as 5,000 hectares. As since 1 hectare is equal to 10 to the power 4 meter square. Now inflow 6 cubic, cubic means meter cube per second. If we convert it in meter, so we have 6 into 30 into 24 into 60 into 60 upon 5000 into 10 to the power 4, as 1 hectare is equal to 10 to the power 4 meter cube. So we can have 6 cubic is equal to 0.3311 meter. In the same way, outflow 6.1 cubic is equal to 0.336 meter. Now if we apply the water budget equation, we can have our desired value, that is denoted by S2, and S1 is and S1 is the and S1 is the surface elevation which is given from arbitrary datum level. So we can have, by calculating through using water budget equation, that is 0.311 plus 0.1455, that is inflow, minus 0.336 plus 6.1 into 10 to the power 2. Why it is? Because if we convert the unit into the right way, that is outflow, so is equal to S2 minus 103.2, that is S1, that is the change of storage. S2 must be must be greater than S1, so I put S2 before 103.2. So S2 is equal to, if we calculate whole things, so we can have S2 is equal to 103.259. So so the increased value will be after 1 month will be 103.259. S2 is equal to 103.259 meter. So that's all for today. Stay safe and stay healthy. Thank you very much.